Hello, my dear friends. So, summary of the last lecture we have discussed about the origin of quantum mechanics, and in that lecture we have discussed the limitations on the classical mechanics and other subject of the physics, and one of the new subject which originates, that is the quantum mechanics. And today we will discuss the black body radiation, and this point is also involved in that origin of quantum mechanics point, but today we will discuss it in detail. Sorry. According to the classical physics, the particle is characterized by its energy and momentum, whereas the wave is characterized by its amplitude and wave vector, that is k bar, and magnitude of k bar is equals to 2 pi by lambda. It is the value of that wave vector, and it gives the information about the direction of that propagation of vector. Now, what is this black body? Why we give the name such a substance or such a object as a black body? Because suppose radiations, some radiations was incident on an object, and that object absorbed all that radiations. If that substance or object absorbs that all radiations which has the different wavelengths, but it absorbs all, therefore it gives a color that is the black, because all colors are mixed in that material. Radiations means all colors, that wavelength, because you know the wavelengths, red color wavelength is different, yellow color wavelength is different, pink color wavelength is different, all colors has the different wavelengths, and all these wavelength color are mixed, that radiations are absorbed by that body, therefore it reflects a black color. Therefore we consider that substance or that object as a black, therefore we give the name as the black body. If that object placed in a thermal equilibrium position, and at that time all wavelengths, all radiations are incident on that surface of that the object, and it absorbed all that radiations, and if we heated that material with increasing temperature, at that time it it changes its color, from which first, if it absorbs the all ranges of that colors radiations, at that time it has a color that is black, and after that it changes, while heating it changes its color, that is first red, then it changes its color to yellow, then its color changes to white, and this color, we can see that color because at that particular temperature the maximum the radiations was emitted, that that radiations has the wavelength of that particular color, therefore we seen that color at that time. Therefore suppose the that black body radiates the red color, then we will see the red color of that object. Is it okay? Okay. Suppose now the frequency or intensity frequency of that emitted radiations is dependent on the its in sorry, the intensity is dependent on its frequency and the temperature, Now we have given here the graph, here the frequency, that is intensity and temperature. These three parameters are dependent on each other. Now here we give the laws and its statements. We will discuss it later, but first we discuss one experiment related to the black body. Experimentally, we take a one cavity whose internal walls are perfectly reflection, or that is made by the any metallic which reflects, which are good reflector. When the radiations, that cavity, that object has a one small hole, and when the radiations are incident on that surface and passing through that the hole, that means it absorbs all that radiations, and while we heat that subject or the substance or object, that time it emits that all radiations. Means at the thermal equilibrium, the black body is the perfect absorber as well as the perfect emitter. Means how much radiations was absorbed by that body, that much amount of radiations will emit from that surface or that object. Therefore we call it as the, it is the perfect absorber as well as the perfect emitter. Now we will see one by one the laws and its statement regarding the black body radiations. I told you about the black body, but if we heat that substance and radiations are emitted, that is nothing but the black body radiation. Now we will see the laws which are developed one by one, and finally the Planck's law gives all this black body radiation finally. Now first law, that is the Stefan Boltzmann law, and that is the E is directly proportional to T to the power 4, means E is the energy and T is the absolute temperature, and it states that the total radiate heat power emitted from a surface is proportional to the fourth power of its absolute temperature. Means energy is directly proportional to the fourth power of the absolute temperature. Now second law is the Wien's law, and that is the lambda max is equals to B by T, means lambda max is inversely proportional to the temperature, and B is the Wien's displacement constant that has value 2.8977 into 10 to the power 3 meter Kelvin. Now third law discovered by the Rayleigh-Jeans law. I kept here name as a relay, but it is the Rayleigh-Jeans law, and it gives that E nu is equals to 8 pi nu square by c cube into kT, and it states that the intensity emitted by a black body is directly proportional to the temperature and inversely proportional to the wavelength raised to a power of 4. And finally the Planck's law, which gives the E lambda is equals to 8 pi Sc divided by lambda to the power 5 e to the power Hc by pi kt minus 1, and the statements is that the electromagnetic radiation from heated body is not emitted as a continuous flow, but is made up of discrete units or quanta of energy, size of which involves a fundamental physical constant. Now last we see the law of Planck's, and Planck gives the statement that energy exchange between radiation and matter, that is in the discrete form, that is must be discrete. The word must be discrete, and the energy exchange between that radiated electromagnetic waves and the matter, that is the integral multiple of that frequency nu and the matter. And this energy density is neither be dependent on the chemical composition of that object and nor its the shape, but it depends on the temperature. If we increase the temperature by any any degrees in Kelvin or in Celsius, if we increase the temperature, and that time only intensity is increased for that particular temperature. That if we increases the temperature, then increase in the intensity. Okay, and that is all about the black body radiation. And thank you for watching this video. Also subscribe my channel Jnani Physics World.